So the age of invertebrates without backbones. Primordial soup, love it or leave it. Say no to backbones. Guys with magnifying glasses. Worm with a chase lounge. That's the little guy from the Cambrian explosion. There's a few of them here. Sucket bobs. Why this guy's carrying a head, I couldn't tell you. Why this guy's wings fell off, I'm not really sure. Helicopter critter. I want to talk about, we're going to go through a bunch of animal groups. We're going to look at plant groups first, but the kingdom, the plant kingdom that we did when we did the kingdoms, is actually considered to be a land group. Is that some of them have gone back into the ocean, some of them have gone back into freshwater for sure. But the ones that have been in the ocean all along, remember I said they at some point used to be in the plants and then they got demoted to the protists. I'm not really sure why. I'm not a plant person, so I wasn't in on that development. But plants are considered to be a land group. And that's what we're going to be dealing with in the next couple of chapters. In the animals, we've got now we will cover these later, but just to get them on the list, insects are considered a land group. The crustaceans in the arthropods are the major water group. And insects, for as successful as they've been on land, and they do okay in freshwater, there's virtually no saltwater marine, what they call marine insects. Is the crustaceans already had those niches filled very effectively. So there really wasn't any place. The closest thing you can find to a marine insect is there's a type of water strider that you may find near the edges of the oceans. Doesn't really qualify, right? Arachnids, you tend to think, for people that are familiar with the term, spiders, but this is the spiders and the scorpions and the mites and the ticks. And so we will talk about those later, but they're all considered land groups. The millipedes are considered land groups. The centipedes are considered land groups. There's a couple of other minor arthropod groups that are considered land groups. In our phylum, in the chordates, but the ones with the backbones, you got the amphibians, the reptiles. Now it gets a little tricky. The dinosaurs are typically classified as reptiles and the birds are classified as birds. I very strongly suspect if the dinosaurs were still around, they'd be classified in their own group, separate from the reptiles, because the more they find about them, the less they really fit well into the reptile group. And the more they discover about birds, the more it's pretty obvious that birds are the surviving group of dinosaurs. But nobody really wants to split the groups or merge the groups. Well, not nobody. Some people have already started classifying birds as dinosaurs. But the major vertebrate groups we're going to look at the very end of the semester: the amphibians, the reptiles, the birds, and the mammals. Our group is considered a land group. Yeah, there's some mammals like whales that have gone back into the water, but they're still much more closely related to us than they are to fish. They superficially look like fish, but it is superficial. It is convergent evolution. Got his baseball and his glove and his bat, but all of the little signs say extinct. Suddenly, Bobby felt very alone in the world. Mass extinctions happen. We kind of mentioned them a little bit earlier. A mass extinction is classified as when you're looking through the sedimentary record, right? We determine and connect layers in different places by the living things that are in those fossils. And when better than 50% of them disappear from one layer to the next newer layer, that's considered to have been a mass extinction. So what makes that happen? Usually, what's going to give you a mass extinction is some occurrence that wipes out most of the plants, takes out the bottom of the food chain. Once you've wiped out the bottom of the food chain, the rest of the food chain tends to tumble after. So you lose lots and lots of animals with anything that takes the plants out. Now there is one modern cause of mass extinctions, well, modern in that they've come up with it fairly recently, that may or may not have taken the plants out. I will mention that right at the end of the causes. Here's North America, here's Mexico, here's the Yucatan Peninsula, and using a particular type of radar, you can look at the subsurface layers and see where they've been scoured out, where they've been crushed, impacted, and there's the remnants of a 60 million year old crater, big crater, which has been traced back to around the end of the dinosaurs, right? We tend to connect the end of the dinosaurs with an asteroid impact. Big old rock, estimated to be about the size of the island of Manhattan, coming in and hitting not just anywhere, but a particular spot where a tremendous amount of particular types of dust were thrown up into the atmosphere that would stay up for a really, really long time and blanket the earth and block the sunlight. And wipe the plants out. Well, not completely, but enough that it wipes out the larger animals, which depend more on food coming up the food chain. Impacts can be asteroids, big rocks. It can be comets, which are big snowballs, basically. Some people have connected the impacts to a weird cause. When you look at the mass extinctions, they follow sort of a 26 million year cycle, where about every 26 million years you get a mass extinction. And when you start to see something, I mean, it doesn't work exactly, but it's close enough that people will go, oh, we gotta explain something. Some people believe that there is a dark member of the solar system that instead of going around in a circle, goes around in a long ellipse, where it spends most of the time way the heck out here where we can't even see it. And then it occasionally comes in, never really that close, probably not even as close as Pluto, which is way the heck out there. But close enough that it disturbs, beyond Pluto, there's a lot of orbiting rocks, what they call the Oort cloud. And the theory is that when Nemesis comes in every 26 million years, it gravitationally disturbs rocks in the Oort cloud and sends them hurtling toward the sun. And sometimes we get in the way. And this idea, They thought they had pretty much shown that there wasn't a nemesis a few years ago. Now they're back to thinking maybe looking at the math of how the planets and the Oort cloud moves, maybe they have an idea where it is. It's one of those things that nobody's really settled on yet. But this is connected to the idea of impacts. Is that, what causes the rocks that otherwise aren't really going that close to the Earth? Although we got one going by in about 10 or 12 years, supposed to be going by pretty close. Maybe too close. In the early 1800s, there was a major volcanic eruption in Indonesia, which is where Wallace was. If you remember the map, it's a long way away from us. Just one volcano, big for a single volcano, but not huge. But it threw enough dust into the atmosphere that it affected the weather for a couple of years afterward. In New York, long way from where the volcano erupted, they called it the year without summer. There was enough dust screening the atmosphere that it snowed in New York in July. And it was a very, very bad year for crops. Now, at certain points in the past, there have been whole volcano fields that have been active, what they call the Siberian Traps, during one of the mass extinctions, throwing huge amounts of dust in the atmosphere. Almost all of India was covered with volcanoes at another period in the past. And so if you crank out a lot of volcanic material into the atmosphere, you can go after the plants and do a pretty effective job. We talked before about how the continents move around. They mush together, they separate out, they mush together in other configurations, and they separate out. Well, all of that changes the way that the oceans circulate, and it changes the way that the air circulates. And sometimes you stop being able to distribute heat properly. And large parts of the areas away from the tropics get really cold, or sometimes the whole planet in the case of the snowball period. And of course, the colder it gets, the snowier it gets, the drier it gets, the worse the plants do, and the bigger the odds that you're going to produce a fairly major ice age. Is that the ice age that we went through fairly recently? I mean, it was still thawing out when the Egyptians were building pyramids. That's pretty recent. But it wasn't considered a mass extinction ice age. But our ancestors definitely were dealing with the repercussions of that for a while. But this mostly is connected to continental drift. Rats. Certain astronomical events like supernovas or other types of things that could be a good long distance away from us, like tens of light years away, sometimes maybe within 100 light years away, can throw massive amounts of radiation that just sweep across solar systems. And one of the biggest of the mass extinctions, where something like 95% of everything was gone from one layer to the next. The last thing I saw, and I saw this within the last week, is people speculating that it might have been one of these astronomical events producing gamma rays. I've seen it explained as an impact. I haven't seen it connected to volcanoes, but I don't know how much of an impact on the plants it would have. It would basically affect everything, right? Radiation, big deal. Sometimes something you see on the list, I'm going to say shouldn't be on the list. Diseases do not cause mass extinctions. Diseases can make species go extinct, but even then, that's unusual. Because diseases are typically caused by living things getting into other living things and messing them up. And both of these things are evolving. The hosts are evolving, the disease organisms are evolving. Number one, it's unusual for disease organism to affect a whole bunch of different species all at once, right? It's weird that this coronavirus came from a bat into people. That doesn't happen a lot. So it's not, our COVID is not wiping out. It affects minks. It affects bats, but it may not be killing the bats. It can apparently live in a couple of other animals, but it's not really good at it. So, it's a major problem for us, but it's not gonna wipe out 50% of all the animals around here. So, also, typically, when a disease moves from one species to another, it's not good at it. May have been good in living in the original species, not so good at the new one, tends to make them sicker, messes their chemistry up more, tends to kill more of them. But if it's a contagious disease, part of its evolutionary need is to make offspring and get them to a new host. Just sitting in a host until the host dies, not doing this population much good. And the more effective variants, mutations and such, are the ones that can keep the hosts up and mingling longer. Is that right now we're seeing the more contagious variants of the coronavirus basically spreading and becoming the dominant variant in parts of the world. Now this already, the COVID is not a super deadly disease. It's wiping out enough people that it's bad, but it's certainly not in any danger of wiping humanity out, especially since most of the humanity it's wiping out are not reproductive members of humanity. But disease is not going to be a major contributor to mass extinctions. Okay, that is it for that particular chapter, and that is the end of section 1. Section 2, we're going to get into the plants.